Hello everyone, my name is Kim Simino and hopefully you already know that. I'm one of the science teachers at Foothill High School and this is my first attempt at doing a vodcast. And basically what that is instead of receiving a lecture in class, you're going to be watching them at home. That way you can get help with the material, we can do more labs, spend more time answering questions in class. As we go through these vodcasts, remember that it's important that you complete your notes, whether they be answering questions or the Cornell note style. You also want to make sure that the most importantly you're hitting the pause button. And this is, I think, going to be one of the most unique and helpful features that we'll have as we do these podcasts. So basically now you can pause the teacher. So if you're not sure of something, if you didn't have time to write down the notes, now just hit the pause button and you can complete those notes. Also, the other thing I want you guys to do is make sure that you're writing down any questions that you have. Maybe put a little question mark, write a full question out, something to help remind you that when we do discuss these podcasts, that you remember what the question is so I can help answer it the next day. So the three things, you guys, are complete your notes, hit the pause button to make sure you're taking complete notes. Maybe you didn't understand something so you can rewind it. And the third thing is to write down questions on your notes sheet. So let's go ahead and get started. So the first slide here, it says Chapter 1, Introduction to Chemistry. And it says, oh no, not chemistry. Yes, chemistry is probably the most challenging class that you will have in high school. But if you are putting your 20 minutes in a night, if you're studying, if you're asking questions, if you're actually participating in class, you're going to do fine. So no worries there. Okay, so the next slide we have here is the objectives. I like to leave the objectives here in our presentations because this lets you know exactly what are your possible test questions. What do you need to be taking away to help you with future assignments? So our objectives today, besides knowing what chemistry is going to be to identify the 5 areas of chemistry, discuss the difference between pure and applied chemistry, and just think about some reasons that we're studying chemistry. So this next slide here, it gives you a definition of chemistry. It also talks about matter. So it says chemistry is the study of the composition of matter. So matter is anything with a mass and that occupies space, its composition, properties, and changes it undergoes. It's kind of a big, messy definition. We'll see a better, more concise one on the next slide. So basically we're studying matter. That's what it is in chemistry. And then therefore matter is anything that has mass and takes up space. Chemistry has a definite effect on your everyday life, the taste of foods, the grades of gasoline. So those are some examples of why you'd want to study chemistry, why you should know and understand it. And then it also says down here at the bottom that living and non-living things are made of matter. So a rock is made of matter. I am made of matter. An important thing to know, probably an interesting test question, is what are things that are not made of matter? So if it's not matter, it doesn't have mass and it doesn't take up space. So these are generally forms of energy. They could be like sound waves, they could be heat, they could be light. So we generally consider those things to not contain matter. So this is the slide that I like that has a better definition of chemistry. So here it says chemistry is the study of the composition. So what's it made of, the structure, and the properties of matter and the changes that it undergoes, such as burning fuels. So again, composition, what is it made of? Structure, how is it made? How is it put together? You guys have all looked at atoms, how are the atoms stuck together? And what are the properties? So what can it do? What can it change into? What can it bond with? And then next unit, we'll be talking about changes, so physical and chemical changes. They also give us a chemical equation down here at the bottom. So you probably can't read this now, but hopefully by the end of the year you'll be able to. This is basically telling you that ethanol is reacting with 3 oxygen molecules. This arrow sign means yield or produces 2 carbon dioxide molecules, hopefully you know what carbon dioxide is, and 3 water molecules and energy. So by burning ethanol in the presence of oxygen, it yields 2 molecules of carbon dioxide, 3 of water, and some energy. So that's something that we'll know. But what I really want you guys to take away from this slide today is, you see these little arrows down here at the bottom? This one says reactants and then products. So reactants are the starting materials. So we're starting off with ethanol and oxygen. And then the products are the final things that are produced, which are carbon dioxide, water, and energy. My All-time example of reactants and products is making pancakes. I make them all the time on the weekends for the kids, sometimes for dinner if I'm feeling lazy. And so reactants in my pancake mix is the pancake mix, the powder stuff, eggs, and water. So those are like my ingredients. And then my products are, of course, the pancakes that I produce. So reactants are starting materials, what are going to react together, and then products, what are the final things produced. So look at the word names, and they kind of help you along as well. This next slide here, it talks about the 5 major areas of chemistry. So the definition we gave you of chemistry is pretty broad, so a lot of times people will divide it up into different areas. The first area is analytical chemistry. This is concerned with the composition of the substance. So look at the word here, analytical, kind of sounds like analyze. So we're just analyzing the composition, or what is it made of. The next 2 on here I'm going to talk about together are inorganic and organic chemistry. Hopefully you remember from biology that if something's organic, it contains carbon, and if it's inorganic, it doesn't have carbon. So inorganic chemistry studies things that don't contain carbon, and organic chemistry, things that do contain carbon. Biochemistry is the chemistry of living things, especially for you guys that are like pre-med, pre-vet, pre-health sciences somehow. Biochemistry is an excellent area to study when you get to college, and it deals with the chemistry of living things. And the last one, physical chemistry, describes the behavior of chemicals, so stretching, and this one it does involve lots of math. But the cool thing here is, let's say you're interested in building a lighter aircraft, more productive solar panels, better types of biofuels. This would be the area that you'd want to study physical chemistry. Down here at the bottom, it does say that the boundaries are not firm, so while we can separate them, often the areas do overlap and interact, and I think we'll see an example on this next slide here. So here we go. Here it gives our little topics again. That's my dog scratching on the ground. Physical chemistry. A physical chemist might study factors that affect breathing rates during exercise. Okay. Organic chemistry. Athletes inhale chemicals developed by organic chemists to control symptoms of asthma. So these areas, but when we're studying these symptoms, it kind of reminds you of maybe a little biochemistry down here. So these areas basically can overlap. They're not hard and fast rules. So going along with our next objective, which was knowing the difference between pure and applied chemistry. So pure chemistry is where people gather knowledge for the sake of knowledge. So they're studying chemistry because they think it's cool, so because they want to know more about it. Applied chemistry, on the other hand, is using chemistry to attain certain goals in fields like medicine, agriculture, and manufacturing. It leads to an application. So those things I mentioned a minute ago about building a lighter aircraft, making more powerful solar panels. So we would be applying the information here. Pure chemistry, you're just studying it. And I often feel that a lot of times we study a lot of pure chemistry in our chemistry class because you need to have a base before you can apply the knowledge. Nylon's kind of an example of a chemical thing. Nylon doesn't occur in nature. It's made by chemists. It's very useful. Clothing, bulletproof vests, nylons, those types of things. Aspirin here is another example of something that chemists, that not necessarily natural. You can find some aspirin in bark and stuff like that, but the kind that you get in the store is produced by chemists to relieve pain. And then here is our last objective. Why do we want to study chemistry? Everyone and everything around us involves chemistry. It helps explain our world, why things interact the way that they do. What in the world isn't chemistry? So look around your room. Probably a chemist had something to build and manufacture that. Helps you make better choices, makes you a better informed citizen. I think this is really critical for students your age because we have so many things going on. We've got climate change going on. We have issues with cloning, genetically modified foods. We have, reproductive concerns. So being informed about it helps you make better decisions because if you don't know anything about it, you obviously are not informed and can't make a good decision. So possible career for the future. I'd mention this if you're considering be pre-dental, pre-vet, pre-medicine. Chemistry is going to be very, very important that you have a background in it. used to attain specific goals. This kind of goes back to this idea that if you want to apply anything, also, if you want to work in engineering or manufacturing, and then what did we describe as pure and applied chemistry? Remember, pure is we're just studying chemistry for the sake of knowing chemistry, and applied for making something being useful with our knowledge of chemistry.